This section, we're going to talk a little bit about geometry. So this is mainly going to help those students that are going to go into trigonometry. And there is, this one, there's no really a chapter on the book, but it's good to know a little bit of the trick behind it. So we're first going to start off with a right triangle. So we have a right triangle here. And then we're going to have an angle. So this angle is going to be theta. So this theta can be like 45 degrees, 30 degrees. So it can be anything that I want. Now, the angle that is right across from it is what we're going to call opposite, because it's opposite of that angle. The this one that's kind of right next to it is what we're going to call adjacent. And then the longest side of this is what we're going to call hypotenuse. So we know that from a right triangle, if I have a right triangle like this, I can call these A, B, and C. And I know that there's a formula that makes me relate all of these sides, which is just A squared plus B squared equals C squared. And we call this a Pythagorean theorem. Okay, now what we're going to do is we're going to try to relate the angle with ABC, which is what we call the opposite, adjacent, and hypotenuse. So in trigonometry, there is 3 different types of trig functions. Okay, so those functions, the first one is what we're going to call sine. That's the first trig function. The other one is called cosine, and the other one is called tangent. And these have a little bit of an abbreviation. This one I'm going to call the sine of theta. Okay, so it's the sine of the angle. This is going to call the cosine of the angle, so I'm abbreviating it. This is going to be called the tangent of the angle. All right. Now, how do I define these? So the sine of the angle is going to be equal to the opposite over the hypotenuse. The cosine is going to be the adjacent over the hypotenuse. And the tangent is going to be the opposite over the adjacent. Now you're probably wondering, how am I going to memorize this? Well, there is a little mnemonic device that you can remember, and that's just so, ka, toa. So you can remember this thing. S here stands for sine. O stands for opposite, H stands for hypotenuse. C here stands for cosine, A is adjacent, H is hypotenuse. T stands for tangent, O stands for opposite, A stands for adjacent. So if you remember SOHCAHTOA, you can remember what each angle is, or what each side means. So let me give you an example. Find sine theta, cosine theta, and tangent theta. Okay, so here's a triangle, and it's a right triangle. This only works if it's a right triangle. Theta is right here. I know that this is 4, and I know that this is 5. Okay, so figure out what sine, cosine, and tangent is. Well, here we have a problem because in order for me to know what sine, cosine, and tangent is, I need to know what all of the sides are. So I don't know what this other side is. So I need to try to do something else to try to figure out that one. Now, in order for me to relate this other side, I know that the Pythagorean theorem can relate all 3 sides. So I'm going to use a squared plus b squared equals c squared on this problem. So A and B can be whatever we want. C must be the hypotenuse. C must be hypotenuse. Okay, it has to be the longest side. Okay, so A, let's just call this A. I'm going to call this A. So A squared, I don't know what it is. B in this case is 4, so I'm going to have 4 squared equals C squared, which is 5 squared. So A squared plus 16 equals 25. I'm going to subtract by 16 to both sides. a squared is going to be equal to 9. I'm going to take the square root, but when I apply a square root, I also add plus or minus. A equals plus or minus 3. Now, if you think about it, can you have a negative length for a triangle? Well, actually, no, you can't. So we can actually ignore the negative 3, and this is actually going to be a positive 3. So this part is just going to be a positive 3. Okay, now let's label it. Let's look at where angle theta is. Here's theta. This part is going to be the opposite. This is going to be the adjacent, and this is going to be the hypotenuse. So now let's figure out what sine, cosine, and tangent is. So sine theta. Sine theta is going to be the opposite over the hypotenuse. The opposite in this case is 3 over the hypotenuse, which in this case is 5. So the sine of theta is equal to 3/5. What is going to be the cosine of theta? The cosine of theta is going to be the adjacent over the hypotenuse. In this case, the adjacent is 4 over 5. That's going to be the cosine. And finally, what's going to be the tangent? Well, the tangent is going to be the opposite over the adjacent. The opposite in this case is 3 over 4. That's what it is. Okay, let's do one more problem. Find sine theta, cosine theta, tangent theta. So here is my triangle. Now theta is going to be up here. Okay, and now what I have is that this is 13 and this is 12. Okay, so now theta's in a different position. So now the first thing that we want to figure out is find the missing side. So again, we're going to use the Pythagorean Theorem. So I'm going to label this A. So I'm going to have a squared plus b squared equals c squared. A, I don't know what it is. B is going to be 12 squared. C is going to be 13 squared. So that's going to give me a squared plus 144 equals 169. I'm going to subtract by 144. So a squared is equal to 25. Take the square root. I don't really need to add plus or minus because I know that this is the length of a triangle. So it's just going to be 5. So here this a is going to be equal to 5. All right, now we have to be very careful because our adjacent and our opposite are very different. This is still the hypotenuse. The 13 is still hypotenuse. It's still the largest number. It's still the hypotenuse. Now the opposite is going to be whatever's opposite of theta. So theta is here. So now this one is going to be my opposite. And this 5 is going to be next to it, which is going to be my adjacent. So those have switched already. Okay, so be very careful. So let's first start off with the sine of theta. Sine of theta is going to be the opposite over the hypotenuse. In this case, it's going to be this 12 over this 13. The cosine of theta is going to be the adjacent over the hypotenuse. This case is going to be this 5 over this 13. And then the tangent of theta is going to be equal to the opposite over the adjacent, which in this case is going to be 12 over 5. Now, typically, you don't want to write them in decimals. You'll see, for those that are going to take trigonometry, that these are actually better to work with later on. So that's all there is to this section of trigonometry.